When we're presenting data, we need to understand not only what the data are saying, but the underlying mechanisms that are at play. After all, it's one thing to be able to replicate something, but it's another entirely to be able to explain it. In this class, we're in the business of explaining our findings. So let's start at the beginning. What data are you going to be working with? First, we're going to want to talk about types of data. This is relatively straightforward and something that you will have noticed when we were working with databases. A whole number is different from a number with a decimal, is different from text. This is an important fact to a computer, which needs to store these data in different formats. Now, it's certainly a consideration, but it's also not what we're concerned with. Rather, let's consider these data. Here, we have 4 different variables in a table. We have students' IDs, their accrued credits, their class ranks, and their SAT scores. All these are numbers. In fact, all these are whole numbers. But these are 4 variables that represent 4 different levels of measurement. Let's unpack this a little bit more, starting at the most general, which are nominal data. Nominal data doesn't have any meaning beyond its use as a label. All text is nominal, but numbers can be as well. UPC codes in supermarkets, for example, are nominal. You can't take the UPC of a lemon and the UPC of sugar and add them up to get the UPC of lemonade. Rather, they're just there to act as an identifier. A nominal variable can also identify a category as well. For example, a student's major would be a nominal variable, even if we coded them with numbers. All identifying variables are nominal, but not all nominal variables are necessarily identifying. Getting one step more descriptive than nominal data is ordinal data. Here, the variables have a defined order, but that order isn't necessarily consistently spaced and doesn't give us any more specific information. For example, the Saffir-Simpson hurricane wind scale categorizes hurricanes between categories 1 through 5. A category 4 hurricane is always going to be stronger than a category 3 hurricane, which is always going to be stronger than a category 2. But we wouldn't infer the exact strength of a hurricane without consulting a lookup table. Generally, all rankings are going to be ordinal. The first place runner is always going to be faster than the second place runner, but the placement data doesn't tell us by how much. We just know that they were faster. One level more descriptive is interval data. Here we have a defined and consistent difference between points, but the 0 point is arbitrary. The classic example of interval data are temperatures. 0 degrees doesn't indicate no heat, it indicates 0 on a scale. Notably, this works on both Celsius and Fahrenheit. Both these scales have a consistent difference between degrees, but in both cases, the 0 point is whatever somebody made up. The freezing point of water for Celsius, or the coldest it usually gets in Gdansk for Fahrenheit. The 0 point's arbitrary nature is critical. 40 degrees in either scale isn't twice as hot as 20 degrees. But the difference in heat between 20 and 30 degrees is equal to the difference in heat between 30 and 40 degrees. In other cases, there's no 0 point at all. Consider that if you answer every single question incorrectly on the GMAT, you don't get a 0, you get a 320. Now, somebody watching this undoubtedly scoffed at my temperature example and said, well, yeah, whatever, but what about Kelvin? To which I say, thank you for setting up my segue. For those of you who aren't pedantic nerds, Kelvin is a scale that starts at absolute 0, which is the complete absence of heat. Now, in this case, we could legitimately say that 40 Kelvin is twice as hot as 20 Kelvin. Now, mind you, both cases would still be cold, but whatever. The key here is that 0 Kelvin represents the complete lack of heat, which is to say it's not an arbitrary point. We call this ratio data, so-called because the meaningful 0 allows us to form ratios from it. 2 gallons of water is half as much as 4 gallons of water. Not only are the intervals defined, in this case 1 gallon, but we can make ratio comparisons because 0 gallons represents a true 0. In the other direction, 50 miles an hour is twice as fast as 25 miles an hour. I learned that one from Traffic Cop. So let's go back to our original table. There are 4 columns and 4 levels of measurement. Which variable is measured at which level?